Now let's recall the expression for the output voltage for an integrating op-amp. Our output voltage is going to be equal to minus 1 per RFC times the integral from t is equal to 0 to t of v n of tau d tau. Now let us consider an example using a summing integrating op-amp. Let's consider a situation where we have two voltage inputs. We want to integrate the sum of these signals. Our first voltage input, v1 of t, is equal to 10 cosine 2t, and v2 of t is equal to 0.5 of t. We want to determine v out, assuming the system initially has 0 voltage potential, given that the resistance of v1 is equal to 3 megaohms, and the resistance associated with v2 is equal to 0.1 megaohms, where our capacitance is equal to 2 millifarads. For us to begin, we want to apply KCL at node A, such that we can relate our input and output voltages. At node A, we have I1 that corresponds to V1, and I2 that corresponds to V2. IA, the current entering our inverting terminal of our op-amp, is going to be assumed 0. Lastly, we have IC running through our capacitor toward our output node. Now, if we apply this in terms of Ohm's law, I1 is simply equal to V1 per R1, since VA is equal to 0. I2 is equal to V2 per R2, and this is equal to I sub C, where our current running through our capacitor is equal to our capacitance times the time rate of change of our voltage. And this would be the difference of VA less V out per dt, where VA is equal to 0. Now we have to solve for our output voltage. V out is equal to minus 1 per C times V1 per R1 plus V2 per R2 dt. We have to integrate this expression. V out is equal to minus 1 per RC, the integral of V1 of t dt, plus minus 1 per R2 of c, the integral of V2 of t dt. Or this is equal to minus 1 per c times the quantity 1 per R1, the integral from 0 to t of 10 cosine 2 tau d tau, plus 1 over R2, the integral from 0 to t of 0.5 tau d tau. Or this is equal to minus 1 per c times the quantity 1 per R1, 5 sine 2t, plus 1 per R2, 0.5 per 2 t squared. Now if we substitute in our values for our resistors and capacitors, we have minus 1 per 2 times 10 to the minus 6, this would be ohms per second, times the quantity 1 per 3 times 10 to the 6 ohms, times 5 sine 2t, plus 1 per 0.1 times 10 to the 6, 0.5 per 2 t squared. Thus our output voltage would be equal to minus 0.83 repeating sine 2t plus 1.25 t squared millivolts.